Hello dear students, this is Devang Shah from Engg Institute of Engineering and Technology under the Engg University. Now today we are going to learn about the digital logic design, as the complete subject is based on digital signals, where those digital signals are going to follow a specific logic, and finally the design we have to make for a specific purpose, right? Or let's discuss about the digital logic design. So our first portion is the introduction of digital electronics. What is the digital electronics? Where digital electronics is going to take the input in form of digital signals and will provide the output in form of digital signals. So now we are in a new world which is called a digital world, where we define the digital system is an interconnection of digital modules, and it is a system that manipulates discrete elements of information that is represented in form of binary system or in representation in form of ones and zeros. So this particular digital electronics or digital system that can understand the language of 1 and 0. So based on that, why we are using this digital electronics? Because the system is much faster than that of the analog electronics. So here we are already using all those with the digital electronics gadgets like automated industrial machineries, pocket calculators, microprocessor, digital computers, digital watches, TV games, signal processing, and so on. So we can see in our real life or everyday we are using those kind of gadgets like computer system, laptops, digital cameras, digital flash system, digital watches, and digital cameras, palm top. All those are digital systems. Those are much faster than that of the analog system. So in a way, those digital systems we are using can only understand a kind of digital signals in form of 1 and 0s, right? So our first job is to understand what is this 1 and 0. So this will give us a kind of specific numbering system, and that numbering system we define as a binary numbering system, right? So based on that, this digital system manipulates discrete elements of information, and those information is like, our routine life. We are using the numbers as like 0 to 10 or 0 to 9 and some of the alphabets, and those numbers and alphabets are now going to convert into a form of 1 and 0. So based on that, the microprocessor is going to understand only the binary numbers. So digital systems use the physical quantities called the signals to represent in the discrete elements, and those elements is like in form of 1 and 0. So digital system, the signals have two discrete values like 1 and 0. That's what we are talking about. So based on that, we are living in an analog world. So you can see here the analog signal which is continuously changing with respect to time, but this is not the case of digital signal, because the digital signal having the discrete signal at a time. So you have a fixed value at a time. So you can see some of the example based on this analog signals is converted into a digital signals, and finally the digital signal, the combination of analog and digital signal here represented as the analog fixed 5 plus 5 volt in digital, it considered as a logic 1, and analog plus 0 volt in digital it can consider as a logic 0. So ultimately it's a train pulse or pulses of train that having the information at 1 and 3, right? So based on that, if we consider a kind of numbering system, we people used to have a numbering system of decimals. So in our everyday routine transactions, we are using all those numbers from 0 to 9, and that is our normal numbering system, which is called a decimal numbering system. But computer or microprocessor can understand only the binary signals 1 and 0s. So our job is to convert all those decimal numbers into a binary numbering system. A more advanced version of binary numbering system is like octal numbering system, hexadecimal numbering system that we need to understand. So our first job is to understand what is numbering system. So system for representing the numbers of a certain type. Like example, here there are several systems for representing the counting numbers, and this includes the usual base like 0, 1, 0, or decimal systems like 1, 2, 3 up to 10 and up to 100. So if we talk further about the numbering system, so basically 4 numbering system we have to understand. First is the binary numbering system, So sorry, first is the decimal numbering system, then binary numbering system, then octal numbering system, and hexadecimal numbering system. You can see this particular hierarchy where numbering system is classified into a 4 numbering system, and at the bottom layer all the blocks represents the ranges of all respective numbering system. Like decimal numbering system has the number ranges from 0 to 9. Binary numbering system has the ranges from 0 to 1, so it's 0 and 1. Octal numbering system has a range of 0 to 7, and hexadecimal numbering system has a range of 0 to 9, and alphabet A to F. So A to F represents decimal numbers positions from 10 to 15. So like A is 10, B is 11. Likewise, 15 is represented in form of alphabet F. Now further we talk about a kind of numbering system. So if we consider a kind of decimal numbers from 0 to 7, so in binary, it is represented in form of 1 and 0. So 0 decimal number in binary itself is 0, octal in a 0, and hexadecimal in a 0. So up to 7, you can see the sequence of binary signals, which is, if you take the 3-bit binary system, likewise you can see the digit number 4 is represented by 1, 0, 0, but in octal it is up to 4, and hexadecimal it is up to 4. So binary numbering system you can represent in form of bits. Octal has the range of 0 to 7. So any decimal number, if you want to convert into octal, that range is always from 0 to 7. Same way for a hexadecimal, the range is from 0 to 9, and alphabet A to M. So based on that, if we further talk about from 8 to 15, you can observe the binary numbering system I have now considered as a 4-bit numbering system, where 8 is represented in form of binary is 1, 0, 0. In octal, it's defined as a 1 and 0. And hexadecimal itself a M. So if you consider the decimal number 10 here, so in binary it is a 1010, octal it is a 12, but in hexadecimal it is represented in form of alphabet A. Up to 15, you can observe all the data from 10 to 15. So these are represented in a different representation of codes, or these are represented in different numbering systems. It's like a code, right? So now your microprocessor can understand the language of 1 and 0. By that way, you have to now represent data in based on this numbering system. Now conversion among the basis of this numbering system. So you can see here our job is to convert decimal number into a binary number. Same way, binary number into octal, and octal number into hexadecimal. So in a way, if you check this particular diagram, so decimal number can be changed into, or can be represented into a binary, octal, hexadecimal, and vice versa. So this is what our part of the syllabus is, that we have to convert one of numbering system into another numbering system. So you can find here some of the example based on, like, convert this decimal number into a binary number. So convert 125 decimal number into a binary number. So what I will do, you just here need to understand a kind of method how we are going to convert this particular number 125 into a binary number. So you can check here, 125 has to divide it by 2, and you have to take it out the 1 as a reminder. So you can see, if I'm going to do the 125 divided by 2, the answer is 62, but the remainder is 1. Same way, 62 further divided by 2, answer is 31, but remainder is 0. Same way, the 31 is divided by 2, answer is 15, but remainder is 1. Okay. Now likewise, you have to use this 2 with the answer always divided by 2 up to answer must be 0, and the remainder you have to take it like that one. So if you follow this particular sequence, and that particular number you have to divide by 2 till the answer comes to 0, and you have to separate it out the remainder. So based on that remainder, if you take from bottom to top, see, if you take from bottom to top, this is what my answer is. So here I can consider my answer from MSB to LSB for this particular digital bits or binary bits is, my answer is 1 1 1 1 1 0 and 1 in form of the binary. So here from this particular example we can understand the method how the decimal number is converted into a binary. Same way, this particular decimal number you can also convert into octal and hexadecimal number. Octal and hexadecimal number. So this is in base of 8 and base of 16. So this 125 can be further divided by 8. You will get the octal number. This 125 further divided by 16 till the answer should come to 0, and you can convert this decimal number into a hexadecimal number. So further, if we discuss more examples, like any base system, if you have to convert into a decimal number. So now this way we can convert any binary number into a decimal number. The method is same. So converting from any base to decimal, it's not only a binary, but any base to decimal is done by multiplying by each digit by its weight and summing binary to decimal. So here the binary number is given is 1011.11 binary number, and you have to convert into a decimal. So you can see there, this one is nothing but give the positions of 2 raised to 0. So it starts from the LSB, the least significant bit. Then the decimal equivalent number is 5. 010, the decimal equivalent number is 2, and 001, the decimal equivalent number is 1. So from that particular table, we find that the 5 is represented in form of 3 bit is 101. So right. So if you have a binary number, and if you are taking the group of 3 bits from LSB to MSB, see, you can easily convert any binary number into a octal number. Same way for hexadecimal. See, 2 raised to 4 is equal to 16. So 16 is nothing but the base of hexadecimal number. So 2 raised to 4 is a bit. So here I have to take the group of 4 bits. So any binary number from LSB to MSB, if you take the group of 4 bits, see, you can also convert binary number into hexadecimal number. So see some of the examples like binary to hexadecimal number, and you can see the 4 bits is represented in form of hexadecimal number. So 1011 is represented as 11. So 11 is in alphabet, it's a B in hexadecimal number, right? Same way 1011, again the B, and 10. So you can consider this number as a 0010, and this is a B. So you can convert this binary pattern 1 and 0 in form of the hexadecimal, that is a 2B, right? So for octal numbering system, you have to take the group of 3 bits. For hexadecimal numbering system, you have to take the group of 4 bits, right? So now here further we'll discuss about the more examples like octal to binary. Again, you have to convert this 257 into a binary. See, that's what the octal into binary, you have to make a reverse process. Like each digit of octal number is represented in form of 3 bits of binary number. So your number is 257. So 7 is represented in a binary form is 111. 5 is represented as a 101, and 2 is represented in form of 010. So my answer is 010, 101, 111 in binary form, right? So it's a completely a reverse process. So it's very easy to convert binary into octal and vice versa, binary into hexa and vice versa. So this is now the hexadecimal number, and you have to convert into binary form. You can see the 2 is represented in form of 4 bits, right? Because you have to convert into hexadecimal number. So this is 2 is represented as 0010, 5 is represented as 0101, A is represented as 1010, and 0 is also represented as 0000. So if you combine all this, you will have your answer in a binary form, right? So it's you should understand how we can convert one numbering system into another numbering system. Now why we learn this numbering system? Because your microprocessors, digital electronics, digital system can only understand the binary numbering system, which is the language of 1 and 0, right? So it's a either plus 5 volt or 0 volt. So those signals are called discrete signals. Now octal is one more representation of binary numbers. It is one layer ahead of the binary system. Hexadecimal number is also one layer ahead of the octal numbering system, right? So as long as you want to make your computers or microprocessor system fast, you have to take more number of ones and zero. At the same time, you have to process it, right? Thank you, dear students. This is about the digital systems as well as the different numbering systems, right? If you have any query, please discuss with me. Thank you very much.